So good morning, everyone, at least good morning in Europe. I'm not sure in which other continents people are, so maybe it's afternoon or evening or whatever. While people are still dropping in, let me say a few words about this session. And then while I'm talking, the people can drop in, and then when Janet starts, everybody is there. So welcome everybody to this special session that celebrates the best paper or the most influential paper award from ICPC 10 years ago. It was 10 years ago that Mike Godfrey and I were program chairs of ICPC, and which was then held in the beautiful German city of Passau. Organized by General Chair Dirk Beyer, who did an absolutely amazing job. I still love that conference. Mike Godfrey would have liked to be here, but well, because of the early hour, that is not possible for him, but he is certainly thinking about all of us. So the job was to Mike and myself to identify which of the papers published back 10 years ago turned out to have the most impact 10 years later. What we did was, for each paper, we collected key data, and we did this based on all 23 papers that were included in the ICPC 2012 proceedings. And 23 papers indicates that ICPC that time was a little smaller than it is now. We looked at impact in terms of citations of both original papers and potential journal extensions. And for the top ranked papers, Mike and I furthermore assessed the nature of the impact, looking at the way in which the papers advanced the state of the art in program comprehension research. And out of this process, a very clear winner emerged. And the title of the winning paper was Measuring Programming Experience. And here you can also see it on the slide, Measuring Programming Experience, 2012 versus 2022. Written by 5 authors, which you also see here: Janet Siegmund, Christian Kestner, Jörg Liebig, Sven Apel, and Stefan Hanneberg. What makes this paper important is that it recognizes that programming experience is a key factor in many program comprehension experiments. And given that observation, the paper conducted a literature review and proposes a questionnaire to actually measure program experience. And based on this, the paper further proposes a model recognizing 5 key factors: experience with mainstream languages, professional experiences, functional experience, experience for education, and logical experience. And the authors expanded their work in a subsequent journal extension of this paper, Measuring and Modeling Programming Experience, which appeared in the ICPC 2012 special issue of Empirical Software Engineering that appeared in 2014. The journal extension substantially strengthens the empirical support of the proposed models. Both papers have had and continue to have significant influence. And the key reason for this is that the paper's results are directly relevant to many experiments in program comprehension. Furthermore, the program is exemplary in its experimental design. We can all learn from this paper. The strong impact of both papers is furthermore evidenced by the citations to both papers, which continue to be high. We are therefore delighted to give the most influential paper award to ICPC 2022 to Janet, Christian, Jörg, Sven, and Stefan for their groundbreaking paper, Measuring Programming Experience. We invited the authors to present a reflection and update of this work, and I am delighted that Janet has accepted this invitation. Janet, the floor is yours.
Yeah, thanks, Ari. Thanks for keeping the pressure high for this talk. Really thank you. Thank you so much for this award. I really love ICPC. This was actually my first conference I went to in person in 2010 in Portugal. And till then, really, program comprehension is the key focus of our research. So it actually really means a lot that this still has such a great impact on the research community. And really, we are totally honored that we never would have expected that to get this award. Okay. So before actually diving into what we have done and into the reflection, I would like to say a few words on how this work emerged in the first place, right? So why should we deal with programming experience at all? And so there was a friend of mine, and he was doing his PhD and developed a tool to highlight certain pieces of code. So the standard was that this certain code with a certain functionality got textual annotations to help improve the comprehension process. And the friend developed an approach to use background colors and also wrote an IDE around that. Oh, by the way, this friend was Christian, one of the co-authors. And when I was looking for a topic for a master's thesis, he offered me this topic. And then, okay, yeah, we set out to evaluate whether this tool actually helps developers. And before really diving into that, we first needed to decide on how we would want to evaluate that. So we took a look at what actually is the important task of software developers, and we found that the most important task, what they really do, is program comprehension, and they do this most of their everyday life. And even though the study is old, this still holds true today. So program comprehension really is a really important task. And where the thing is that designing empirical studies, the hardest part about that are confounding factors. So they bias the results. So in our case, they would affect the comprehension process differently than what we would want to observe, right? So we have programming experience, because the more experienced the developer is, the more efficient he will understand source code, independent of whether it uses textual or colored annotations. And there are many, many, many confounding factors. So the general programming skills, for example, or fatigue, or how fast developers can read. And many, 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 many confounding factors. And ideally, we would control all of them, but that's not possible. So we needed to decide on one. And we figured that really programming experience is the most important factor that had the most influence. So we focused on this one to take care of that during this experiment. And I mean, how to control for programming experience? That was the first question, right? So ideally, we would use maybe a pretest that already existed, or we would use a questionnaire that already existed to measure programming experience. But as you might have guessed, none of this existed, or otherwise I probably wouldn't be giving this talk right now. So before actually diving into the topic of whether background colors can actually help, we needed to develop a questionnaire for that. And since this was a topic for a master's thesis, there was not that much time to really do an in-depth analysis. And so we set it for a really, really quick literature review and took a look at papers that measured programming experience. And based on that, we picked out some questions and we asked some programming experts to rate these questions and to evaluate the influence on programming experience. And even deciding on what are programming experts led already to discussions, right? So who was eligible to rate whether single questions really are related to programming experience? And then also we settled again on persons who somehow had a formal education in computer science and who had at least 5 years of practical programming experience and who also worked on at least one large project. And this opinion of this expert panel helped us then to develop a really rough version of a questionnaire that was only applicable for our concrete study, right? And now with this questionnaire, with this really rough questionnaire, we could go ahead and work on the actual topic of evaluating whether background colors help or whether not. Spoiler, they do help for certain kinds of tasks, but they can also be really annoying and make the life of software developers harder. And I wrote in my thesis that, okay, this questionnaire is really a good starting point, but it would be really, really awesome if we had one questionnaire that is more general purpose and that is helpful when we conduct program comprehension experiments. And yeah, this then led to the paper measuring programming experience 3 years later. So again, it took some time from this first version of the questionnaire to really have a more theoretical, more widespread foundation. Okay, now second part of this talk, I will recapture some of the important aspects in 2012. So basically from what we discussed there at ICPC. But first, I like to set some context. So how far away is actually 2012? And actually a lot far. I was afraid of how fast time passes, right? So there was The Hobbit, that was the movie that was released in 2012. Oh, The Perks of Being a Wallflower, really, really nice movie. I wish I could say something about Star Trek, right? But Star Trek Into Darkness was 2013, and the other one before that was 2009, and Discovery was not before 2017. In case you wondered, which you probably haven't. But Ari said I could talk about whatever I want. Okay, also, remember this guy, Philip Baumgartner, he went to the edge of space and then dove back with a parachute. Also, the Higgs boson has been discovered like 10 years ago. And also, I got married in 2012, actually a week after the conference. So, and that's also when I changed my name. So probably, maybe a few of you have wondered how that came into place. Okay, so much for setting the context. Now I'd like to give more background on the 2012 work. Okay, so remember we did a really quick literature review at the beginning, and now we did a really more complete literature review. We looked at more papers and more details, and of course we used the base that we had from the master's thesis. And so this is what we found on how researchers measured programming experience. Many papers just assessed the year, so asked how long somebody has been programming and then said, okay, our sample had an average of X years of programming experience. Still others asked about the education level, right? So is it an undergraduate or graduate level? And then they use that information to categorize the participants into experts and novices. But the thing is that the term experts and novices was used differently across different studies. So maybe in one study, the undergraduate students were novices and the graduate students were experts. But in still other studies, the graduate students were novices and professional developers were experts. And so we had the same term, but they meant something completely different. There were a few papers that used self-estimation, so asked participants to estimate their experience. Some papers used a questionnaire to measure programming experience, but did not say anything about that. And remember, 2012, websites with replication packages was really a rare thing during that time. So there was no way for us to check about this questionnaire. And the same also counts for pretests. Some used a pretest, but there was no way to take a closer look at this pretest. Then there were a few papers, especially when they recruited professional developers. They asked the supervisor to estimate the programming experience. And now the most important finding also was that actually many papers said they measured programming experience, but they did not specify how that. They just said we did. And even more papers, they did not mention programming experience at all, right? So they measured program comprehension somehow, but didn't say anything about how they controlled for programming experience. Maybe they didn't do it at all. And I mean, think about these numbers. It was such an important confounding factor, but so much chaos on how it was measured. So how should we compare the results of these studies? And this really reflects also on the state of empirical research during that time. So we actually have come quite some way from 2012 to now with the quality of empirical research. Okay, so based on these categories that we found, we took them, and then we, based on these categories, created the questionnaire. And basically we took all the questions that people have used and put them together in a questionnaire. So we asked about the years, how long somebody has been programming or programming professionally. We asked several questions about the self-estimation. So for example, participants should estimate their general programming experience on a scale from 1 to 10, or they should estimate their programming experience compared to experts or compared to their classmates, or their experience with certain programming languages or programming paradigms. We also asked about their education. So we asked when they enrolled in a major. And we also asked about how many courses they took in which they had to program. Then we excluded the categories unspecified questionnaire and pretest because we didn't know what happened there. And also, since we were working mostly with students, we also excluded the supervisor estimation in our questionnaire. But we included other questions. So first we asked the participants about the size of the projects they've been working with. And we also asked about their age as possible indicator for programming experience. Okay, so now we have this questionnaire, but now the next step is to evaluate that, right? So we can ask about all these questions, but we need to find something that actually resembles programming experience so that we can relate the answers in the questionnaire to the actual programming experience. And to this end, we developed several programming tasks. So tasks like these, and then we asked participants to mentally execute this method and then print out the results. And the idea behind that is that the more experienced participants are, the better they can answer these questions. So the more programming tasks they can solve correctly in a given time frame. And to evaluate that, we invited participants from several different universities. That was during a time where we could actually just travel without any restrictions within Germany. And I went physically to all these different universities. And for the experimental procedure, we gave them a general introduction where we really roughly explained the purpose to not bias the participants. Then we gave them the questionnaire before the actual study, also not to bias the participants' self-estimation right after the programming tasks, so that they estimate their skills better or worse just based on the questions, but just based on the tasks. Then we gave them another introduction to set the context. Okay, now we want to see how well your self-estimation is. And then we gave them the 10 comprehension tasks for which they had 40 minutes to solve. And then afterwards, we gave them a debriefing, and there we really explained everything, the entire setting, the entire experiment that all this was about. Okay, and as concrete indicator for programming experience, we took the number of correctly solved tasks. And what you can really see here nicely is that it's something that's typical for an undergraduate student population, is that many participants solve 2 to 4 tasks correctly, but only very few are above that. And actually none of the participants solved 9 or 10 of the tasks correctly. And then the number of correct answers was our ground truth for programming experience that we used as indicator and correlated all the questions with. Okay, now the question is, okay, which questions actually do measure programming experience? So which of the self-estimated questions actually relate to programming experience? And intuitively, you would say, okay, questions that have a high correlation with the number of correct answers, they actually are good indicators for programming experience, right? So for example, we had the self-estimated experience compared to classmates, and this actually has a pretty high correlation, so like a medium correlation, we would say. So this might be a good indicator. Then, for example, another indicator could be the years somebody has been programming. And this also has a similar high correlation. But the problem is that these correlations, they are also related to each other, right? So a participant who has been programming for a certain number of years also estimates her programming experience higher compared to her classmate. And if you would want to take these two questions at the same time to measure programming experience, we would overestimate the influence of that these both questions have. We somehow need to subtract the red part. And actually what we only want to take into account is the green part of this correlation, right? So I somehow need to disentangle all these different effects. And one way to do so is stepwise regression. And stepwise regression really is able to just compute the correlations. So it's called the partial correlations that are only relevant in addition to an already existing questions. And what we found in the stepwise regression is that there are two relevant questions that show a good correlation with programming experience. So the first question would be the experience, the self-estimated experience compared to classmates, which has a pretty high partial correlation. And the second one might be a bit surprising, but the second one is the experience in logical programming, right? So the more experienced someone estimates to be with logical programming in general, the higher also is the programming experience, as we found. And so this is for completeness, the result of the regression model, that these two questions are really important to measure programming experience. Now, okay, what does that mean? What can we do with this regression model? So I've prepared an example to compute the programming experience. So suppose we would have someone like my daughter at age 2. I would say she's very inexperienced in programming compared to her classmates. And also with logical programming, she has not that had much contact with. And now we have the regression weights for each of these questions. And what we do then is we multiply the value she entered with the regression weight for the classmates and the same for the logical. And then we have a value for programming experience of 0.7. Now, by contrast, if we would have a really experienced programmer, I would say that she has much more experience compared to her classmates, and also that she's very experienced with logical programming. Then we take the value that she entered and multiply that also with the according regression weights, and then get a different value for programming experience. So this is actually then the minimum value for programming experience, and this is the maximum value that someone could achieve, and this would be the possible range of programming experience. Okay, and then we build on that. So Ari mentioned the journal extension that we did. And since in the first part, we only worked with undergraduate students, we wanted to know if this also works with graduate students. So since we have applied that programming experience more or less in the same, in a similar way in our previous experiments, we just have the data of previous graduate students from previous experiments. And what would be really cool if this questionnaire would be able to differentiate between the undergraduate students and the graduate students, because this would also be then an indicator that it truly measures programming experience, because graduate students, they just have more experience. They just have done more projects, more courses with implementing projects. And we found that the average programming experience value for the undergraduate samples is 1.2, and for the graduate sample is 1.8. Well, it doesn't seem like much of a difference, but remember the scale is not so, has not such a wide range. So actually the difference is considerable. And we also did a significance test on that. And we really found that this difference is significant. So really this questionnaire really is able to differentiate between undergraduate and graduate students, which is pretty cool for our studies with students in general. And then we also built on that. So we went a step further and tried to create a model that describes programming experience, right? So we have so many data then that we could just do this procedure. And what we did here was exploratory factor analysis. So most of you, I think machine learning is pretty well known. So what we concretely did, the procedure was a principal component analysis. And I think that's part of machine learning 101. And so what this approach does is it takes a look at all the questions that we have and evaluates whether there are groups of questions that correlate high among each other, but not with other groups of questions. And what we found was this really interesting model that this group of questions, so the experience with Java and C and the encoding programming paradigms, that they correlate high among each other. And then the idea is that there should be an underlying theoretical construct that describes all these factors, that explains why they have something in common. And we named that one the experience with common languages. And the same counts for professional experience. So we have the questions that really relate to professional experience. So somebody who has been programming professionally for some time, somebody who has worked really on large projects or who really knows several languages. So these questions also correlate high among each other. And that's why we named this factor professional experience. And then we found that the self-estimated experience with functional programming and with Haskell as programming language, as a functional programming language, also correlate among each other. And this is the factor called functional programming experience. And the same counts also for the logical experience, so experience with logical programming. And also we found a factor that describes the experience from education, and these questions are also correlate high among each other. Okay, now one thing that makes this exploratory factor analysis sometimes difficult to interpret is that there are questions that also, that there are single questions that also correlate with other groups of questions. So for example, the self-estimated experience with a C programming language also correlates with a professional experience, right? So this question seems to indicate that somebody has experience with common programming languages, but also some professional programming experience. The same counts for classmates, right? So the self-estimated experience compared to classmates. And people who rate their experience higher than their classmates also rate that they have a higher experience in functional programming. And the same counts also for the years somebody has been programming. So it's not just related to the experience based on education, but also the professional experience. So somebody who has been programming longer also rates their professional experience a bit higher. Okay, so much for what we did in 2012. And now it's time for a reflection. So what happens in 2022? So we thought actually, great, now we have a questionnaire, it's publicly available. The website even still works. So there were some hiccups, but it still works. Everyone can use that. Everyone can use the questionnaire, and we do great program comprehension experiments now. Yeah, but I bet many of you, probably not all of you, even know that such a questionnaire exists. And yeah, so to reflect on this work, what we did was, okay, let's take a look at all the papers that cite our work, right? So we go to Google Scholar, we click on cited by, so who cited this work, and then we took a look at all the papers that mention our work, excluding our own, because we know what we did with the questionnaire. And the results were a bit, how do I say that, a bit unsettling. But let me show you what the results are. So I found work that really applied the questionnaire just like we described it in the paper. So they used these two questions for the experience compared to classmates and with logical experience, with logical programming. They applied the regression model, and then they had the programming experience values for their participants. That was actually one paper in which that was applied this way. Then there were many papers that in which the authors described, okay, based on this previous work, you measure programming experience. But there was no further elaboration. So for example, we would find that authors wrote, okay, questions are based on a well-accepted questionnaire. And then they mention our work. Or they would say, okay, to measure programming experience, we included the background demographic questions by that paper. Or in some cases, the authors explicitly mentioned the questions that they applied, but they didn't describe how the answers to these questions were used to derive a programming experience value. And this was really a bit odd for us, because I mean, there were no websites, right? So we could not check what the authors actually did and which questions exactly they used and how they built their work on that, right? So on the one hand, it's good that it's used, but on the other hand, it's pretty weird that we actually do not know how they did it and what they did with that. Okay, then as further ways, we found that some authors used it as example. So they said, okay, you could measure programming experience. There's some work and there's a questionnaire that you can use that. Or they said, okay, there are also other approaches to measure programming experience. So see that, for example, right? So also interesting that this served as example for other researchers to build on. This is really interesting for us. Still others, they used the question or the work that we had to provide some detailed explanation and to refer to our work to look at more details. So I really find this one interesting. So they said they did not collect self-reported prior experience due to conflicting accounts of self-reported programming ability being a good and a bad predictor of performance. Really interesting fact, one of the authors of this work was actually a co-author of our paper. Found that really interesting. And still others said, okay, self-estimation seems to work. So here's a good example of that, but we cannot do this because in this case, they only had the log data of developers and could not access the experience afterwards. Still really interesting and a bit more concerning for me was that some really freely interpreted the what we wrote in the paper, right? So I find that some used it actually beyond the actual purpose that we have. So some said, okay, we use this questionnaire to categorize into experts and novices without any further explanation, and also based on the original paper, not the journal extension, in which we really said, okay, we can differentiate between undergraduate and graduate students. Still others said, okay, we measure programming language experience with based on this work, but the questionnaire was more universal, right? So they were the questionnaire asked more about more programming languages, and so this we felt it a bit weird that they say, okay, we measure programming language experience, which is not quite true. And still others, they picked some questions that without any really deep elaboration. So some picked the self-estimated programming experience from 1 to 10. But interesting fact, we actually had a technical error in that in the original study. So we could not collect the data from all the participants, only from around half. So actually this is one of the weakest questions that we have in our questionnaire. And still others, they just said, okay, we use the years of programming experience, but remember, this is what was used most often anyway, right? So just this one question was picked without any further explanation of why. And this really feels weird because from my personal perspective, it feels weird. It feels misinterpreted on what the actual work was about. Okay, so, and I also like to reflect a bit on what we wrote in future work during in 2012. So what we said, okay, we recommend to report precisely which measure was used and how groups have been formed according to it, which really would help to compare the results of different studies. But since many said, okay, based on this work, we did that without any further explanation, I would say this is not really fulfilled. Another point that we mentioned is, okay, we should use control questions and combine multiple questions to make sure that the participants really answer honestly and do not answer according to social desirability or something like that, so that their responses are not biased too much. But again, since we do not know what questions were used, it's really difficult to say whether this actually really happened. And also the co-correlations between the questions, right? So that the questions itself also correlate, and we should be really careful in selecting the right questions. And, you know, people just picked their own questions without any elaboration on why this makes sense. I would say also this one is not really fulfilled. Okay, so one excursion to psychology on how to build a good questionnaire. So actually, when building a questionnaire or any test instrument at all, there are actually many terms that are relevant and then should be considered, right? So it's not important to understand these terms, but really the message here of the slide is that there are really many terms that should come up when designing a questionnaire or when designing a test, right? So the green ones are related to equality in general, with the dark green ones really being the main criterion for constructing good tests. And the blue ones refer to single questions. So, and at one point when constructing a questionnaire, these terms should come up, but they didn't in our paper, they didn't in our extension paper. And so far as I've seen, they also did not come up in any follow-up paper about that. So really the question is, what happened? So what have we done in these last 10 years? And I'd like to have one last statement here that, okay, also from our original paper, so we have a good starting point for developing a theory on programming experience. The results may not help to build a survey right away, but we can do additional analysis like confirmatory factor analysis or something like that to really help understanding on what actually is programming experience and what kind of questions are really relevant for that. And that's the last sentence, and I'd like to highlight that. So it still is a long way, which we wrote in 2012. And I'm afraid it still is a really long way. And at that point, I started to wonder, well, why is that? What happened? Why did no one follow up? Why did we follow up on that? Right. And now here comes a really personal reflection. This really is just my view on what happened and not necessarily the view of the co-authors. So when we wrote this paper in 2012, I was an early career researcher, right? I still looked so young and full of hope. And well, I wrote this paper. I got it accepted at my most important conference because I focus on program comprehension. And I could say, oh, okay, check, I have a paper at the conference. Looks good on my CV. And then one step further, wow, we really got invited to a special issue. And only a few of the papers are actually selected, are only invited to do that. Wow, so really check on the quality of our work, which is really good. But then I figured, well, I wanted to get tenure at a German university, making it really, really difficult. And actually no tenure committee in the world, or especially in Germany, would care if I really focused on this questionnaire. If at the end of, I don't know, 5 years, 3 years or whatever, a really fully emerged questionnaire would be the result of the research. So there would be no appreciation that I can use to get tenure for focusing my resources on continuing this line of research. And so I really moved to different projects to show, hey, I'm diverse, I can do other things. I'm not just a Mrs. Programming experience. And so I tackled other projects that really would look good on my CV, right? And this this tackles the entire, okay, publish or perish discussion and shows what can happen, right? If there are no incentives to really focus on something and bring something to term, right? But improvement is already underway. So there are Dutch universities. I'm sorry, Ari, I only found this picture from Utrecht University, but they are starting to abandon impact factors and really focus on open science, and that people really make their research available and not just count the number of publications for people who want to get tenure, which is a really good starting point. And there are also more positive things. So we have now permanent websites. We have Zenodo, we have Figshare, where we can just upload a replication package of the data, and they really make it easy to do that. We can just zip everything and put it on that website, and then these websites are permanently available. And there are also incentives. So for example, there are these ICM badges that you can get for your artifacts, that they have been evaluated, that they actually can be reproduced, the data that you collected, and that they can actually replicate the data of a study, which is a really important step forward for lifting the quality standards of empirical research in software engineering. And there's also the, with the Open Science Foundation, you can pre-register your studies, right? So before collecting any data, you just register the protocol, and then reviewers would evaluate that and say, okay, you're good to go. This looks like a promising study design. Go ahead and collect the data. And this, since 2020, this is also possible in MSR and ICSME, that you can submit your study protocol there for pre-registration. And then if you follow the protocol, you get your paper accepted at the Empirical Software Engineering Journal, even if there are negative results, right? So even if the results are boring, in other words, you still get accepted. And this also is really important to lift the quality of empirical research. And well, to conclude, we actually do have a solid foundation. So we have lots of data on programming experience. We have the first foundation of such a model. And with the standards of empirical research getting better and better, we really now have a good basis to continue this line of research, and not just on programming experience, but on other cognitive constructs. So you're really at a good starting point to build questionnaires, test instruments, and theoretical models of all the constructs that are interesting for us. And it still is a long way to go from there. So we build a basis. Now it's 10 years later, we still have a good basis, but really now we have really achieved as a community way more to build on that and continue this line of research, of really have a good way of measuring cognitive constructs. Oh, okay, thank you.
This calls for a round of applause. So thank you very, very much, Janet. It is now time for questions. And anybody is happy, can ask questions. I see a hand raised, Marvin. Please feel free to switch on the camera and use the mic to ask the question.
Yeah, hello. My camera should be switched on. Can you see me? Yeah,
Yes.
okay. Thank you very much for this talk. Really nice topic, very well motivated study, of course. So we also use this questionnaire in at least 1 or 2 studies of our own.
Yay.
And we tried to stick really close to what you proposed. So we hopefully did not misinterpret what you intended to do. But yeah, I really also appreciate your reflection on why so less people build on this work. And I think your 10-year example makes perfectly sense. I also feel like there is, in addition, this thing that somehow most people in the community want to bring out their own ideas, their own things. They want to build something that is their own thing, right? And so you are the group who proposed this measuring programming experience questionnaire, and somebody who adds on this with an additional validation or something. Yeah, well, how many citations will this person get, right? So it's a bit sad because, as you outlined, there are so much things that we can do now to improve this questionnaire, make it more robust, and so on. I have an idea not for this particular problem. So since people actually need to use this and want to use it because it makes it easier to convince reviewers as well, there is motivation to use this questionnaire. And I think if people use it, it's not their main focus to validate this questionnaire, but since they have the data in the end to show, for example, how individual items of your questionnaire correlate with each other, it would be the minimum to publish these data. And then in the end, we can at least do a meta study or something, right? And see, okay, use all this data from all these studies and then somehow validate it. And maybe that could be a way forward. I don't know what you think we can do to motivate more people to work on other people's things instead of doing their own stuff.
Yeah, that's really tough, actually. I mean, the option is now there. And I think right now it's the state of mind to, okay, I have published my data. Now I don't care what you do with that. Do whatever you want. And no one really pushes on using that, because I still think it's what you said, Marvin, about the reputation, right? I want to be the first to do that. But I have no incentive to go further with that, to really do that analysis. And that's really sad. And also, it's I kind of, it was published in the fMRI community at one point that it's, well, if you use the data of different researchers and then build on that you're kind of a looter, right? That you just use all the effort of all the different people to make it your own, which maybe is also difficult. But I don't know. What would be really cool maybe would be a study to question, or why do you not build on data? Why do you do different research on that, right? To really find out all the factors behind that. If you have time, go ahead and do it.
Yeah, we try to at least I don't know, see in our study, analyze. If we use this question, then we try to analyze what is the best predictor for our case, and somehow see how these items correlate. But yeah, it's almost never the focus, of course, of the study, and you have limited space. So okay, thank you very much.
Just 1 second, I see that Ari disconnected for a minute.
I was kicked out of my laptop, but I'm back again. So sorry about this.
No problem.
Shall I resume the chair responsibilities?
Yes, please.
Then I give the floor to Dort.
Yeah, okay, thanks. So first, I just recommend this. It's very important that this paper, I mean, it wasn't emphasized, but this is a methodology paper, and we don't have enough methodology papers. So I'm really glad that you got this award, and we should have many more methodology papers because without good methodology, all of the rest of our work is much less meaningful. So we should emphasize this. And for those who are worried about published papers, then good methodology papers actually typically get more citations than other papers. So actually, it's a good thing for your career to write good methodology papers. So all of the young people here that are thinking about what they should do, they should certainly not pass by this opportunity. So that's the nice thing about this paper. But putting that aside, so I'm very for this, but I want to make some comments about maybe why it didn't catch on as much as you wanted, and why there have been problems. So I think one of the main things is that it's in a sense limited to students, because if one of the main questions you suggest as a sort of discriminating question, which is good, is how do you rate yourself relative to your classmates, then it means you have to be in class. And it's not a general question for, if you send out a questionnaire on the internet using news groups or whatever, then it's not a general question that everybody can answer. And especially if you are interested in professional developers, especially professional developers which are also more experienced and not only novices, then I mean maybe they never went to class. Maybe they're self-taught. Maybe they learned some other external courses. So it's a very limiting factor. And in a sense, it also this whole questionnaire or tool. And I think it does not really make a good distinction about what the main confounding factor, which we are always dealing with, which is the division between students and professionals. So there are lots of people who say that no, you shouldn't use students, and the other people say no, students are fine, and at least for us in Israel, the distinction is sometimes very hard to make, because a lot of students are, even from their second year as undergraduates, they already have intern jobs or even work half-time or more than that. A booming high-tech industry is a real problem in that sense, because and all of my graduate students are working either full-time or close to that, except not all of them. I now have one PhD student who isn't working, which is very rare. So the distinction is not really necessarily valid, and I admit we don't use your tool as is, but we are in a sense a bit inspired by it. So we try to make the distinction between real novices, like first-year undergraduates who don't know anything, and students who don't have real experience, and people who do have real experience regardless of their academic status. So for example, it could be people who learn to programming. Again, for us, one of the main places where people get their programming education and get really good experiences in the army. So they don't have any academic necessarily. They can come with really top level experience and be first-year students because they want to make up the degree later. So it's a big mess. And we want to ask them about their quote real experience. So, for example, your question about program, what is the largest project size you've ever worked on, which is a sort of rephrasing of what you asked. I think is a very interesting question in that sense. Or what is the largest group of programmers you participated in? So things like that would be interesting to as indicative questions. And one last question is, one last comment maybe is one thing I was sort of not very happy about is a sort of circular argument. So you use program comprehension as the ground truth for experience, and then we use experience to see how different experienced people are good at program comprehension. So that's a sort of circular argument. You define experienced people by how well they correlate with program comprehension questions. and then the question is, if you get that more experienced people according to this metric are better at program comprehension, then it's a circular argument.
Thank you, Dolor. Janet, would you like to react to some of these comments?
Oh, yes, to all of them, if I can. Okay, so first part was that the question of the classmates do not apply for programming experts. And I would agree. I would even add more constraints to that, because we only looked at German universities, right? So different universities, they have different education system. So people may work beside their study, which is typically not in Germany the case. So people really should focus on their study full time, and some may work besides that. Furthermore, this was 10 years ago. I pretty much certain many things changed during that time, and that actually we should do such a study again to be sure if it still holds true today. But what I would like to say is that we still do many studies on on students. And many people do many studies on students, and so there really are an important population to consider, because they at the end they will become professional programmers, and we need to find a way to bring them there. So the applicability is pretty wide, I would say, but of course not for professional developers. And what we would do here would be to adapt this question to professional programmers. So of course the question compared to classmates does not make sense, but we could change that, for example, to estimate with their colleagues in a company, or with their typical peers they would estimate by themselves. This would be one way to adapt this, and then of course we would still need an evaluation to do that. And I wrote something about student versus professionals. Maybe it was that answer anyway. But I like to come back to that circular argument, which actually it's not quite circular conclusions that we do. But I mean, with the program comprehension questions, we did not ask about the program comprehension, right? So we didn't really much care about that. But the thing is, we need a ground truth for a programming experience. And during that time, it was the best option for us to use this as ground truth, because people who have more experience, they should be able to, within the time limit of 40 minutes, to comprehend these tasks faster, just based on their experience. And so they should be able to answer more questions correctly. And during that time, I wouldn't know of any better ground truth that we could have in the population of students. So that's why I hope, so this is actually not a circular argument, but I agree it is an indirection of programming experience, because the ground truth is not programming experience itself, but is something that comes close to that.
Wonderful. There is another question in the chat by Marvin, or I don't think it was addressed yet. Marvin, would you like to explain it?
Yeah. It touches a bit on what Thor asked about the circular argument. I don't think it's a circular argument. In the end, you came up with a questionnaire that is good at predicting the performance in such code comprehension tasks. And for this, it's perfectly fine. You can use this if you correlate other variables and see which influence is stronger. My question is more, so I consider it useful to have it. The question is, what does this assumption imply that your selection of the ground truth for other researchers that want to use your questionnaire, because it's about measuring programming experience, but it's only validated for being a predictor for code comprehension performance, right? So is this the biggest limitation basically? So can only code comprehension studies use this questionnaire, or what would you say?
So I wouldn't say it's the biggest restriction, but of course you're right. Right, so studies who do program comprehension tasks that are similar to the ones that we use, they are really the best candidates to use that questionnaire, because the experience, as we defined in the ground truth, is of course closest. And the farther away these studies are from this actual program comprehension that we used, the less we know if that's really related to programming experience. And of course, we would need more studies to do that.
Yeah.
That's the point. We would need more studies to really extend the range. And really, it's really tough to design questionnaires. So we all discussed the limitations about just students, only Germany 10 years ago, just these program comprehension tasks. These are all limitations, and they are inevitable when we write one paper about that, right? So ideally, it would be a whole PhD thesis to really have this questionnaire and really have a fully validated questionnaire. And that's empirical research, right?
Wonderful. It is 10:50, and in the interest of, at least in my time zone, it's 10:50. And that means that we need to wrap up. So thank you so much, Janet, for this wonderful presentation. Not only was the paper exemplary in terms of methodology and results, I think your presentation was also exemplary in how you can look back and reflect on 10 years of work. So thank you so much. And the picture of yourself with this pile of papers, it's the Margaret Hamilton picture of you. So,
right. Yeah.
So wonderful. So congratulations again. Thanks, everybody. And a last round of applause.
Thank you.